today we have a short glance of what we have discussed in the earlier class, and we will continue further on. Okay. So anti-arrhythmic drugs. Anti-arrhythmic drugs is the third chapter of our syllabus. So anti-arrhythmic drugs are nothing but the drugs which are used to treat the arrhythmia. Okay. You already know what is arrhythmia. Irregular heartbeat. Okay. A stands for irregular. Rhythm stands for beats. Okay. Irregular heartbeats are called as arrhythmia. Okay. So generally, if you see the function of heart, so there should be proper beating of the heart to ensure the proper blood circulation to each and every part of the body. Okay. If you take a section of your heart, you will be having 4 chambers. Okay. This is left ventricle, right atria, and right ventricle. Okay. So in left ventricle, you will be having the oxygenated bed. Here, oxygenated bed. This oxygenated bed will be supplied to your body cells. Okay. Oxygen. After that, it will come as deoxygenated bed. Deoxygenated is nothing but the exchange with carbon dioxide. It will contain the carbon dioxide. This blood will reach to the right atrium. Okay. And from here, the deoxygenated blood will enter into your right ventricle. From right ventricle, it will go to the lungs. Okay, deoxygenated blood, where the carbon dioxide will be exchanged from the oxygen, and you will get oxygenated blood. Okay, that will be dumped into your left atria. From left atria, the oxygenated blood again will enter into the left ventricle. Again, the cycle will be repeated. Okay, this is the general phenomena which is happening in our body. Here, now for this process, for pumping of blood from left ventricle to the cells and right ventricle to the lungs. Okay, this phenomena is being carried by the contraction and relaxation of the heart. Each contraction and relaxation of the heart is called as your heartbeat. Okay, that is nothing but for a normal human being, the regular heartbeat is 72 beats per minute. If the heart is beating for 72 minutes, okay, it will call as dumped up, right? Contraction and relaxation. That 72 beats is essential to circulate the blood, oxygenated and deoxygenated blood. Okay, so this one cycle is called as rhythm. Okay, 72 beats. So now arrhythmia is nothing but irregular heartbeat. Okay, if the heartbeat in some conditions it may go, so generally the heart rate may change. Okay, if the sympathetic nervous system is active for more time, for example, if you are running, the heart rate will increase. If you are resting or sleeping for more time, the heart rate will be little bit decreased. We cannot call it as arrhythmia. Okay, because even though while running it will increase, again it will bring back to normal 72 beats per minute. Okay, that is regulated. Okay, this is regulated in a normal human being. In some condition or some disturbances due to the electrical impulses or some changes or due to atherosclerosis, okay, the overall physiology of heart will be disturbed and the heart rate may either increase or decrease. That can increase or decrease and it will become prolonged. Okay, it will stand for long time. That is called as your arrhythmia. Okay, you will be having 2 types of arrhythmia: tachycardia and bradycardia. Tachycardia is nothing but if the heart rate is above 100 for more time, prolonged time, that is called as tachycardia. If it is below 60 beats per minute for prolonged time, then that is called as bradycardia. Now, why the condition of this arrhythmia will come? Okay, lot of factors will be there. Some of the factors may be cardiovascular disorders or some spasms of the arteries, coronary arteries. Okay, so due to this, the overall heart load on heart will be increased and the heart rate may change. Okay. And in some cases such as kidney cancer, for example, adrenal cancer, adrenaline will be more. If the adrenaline is more, then the sympathetic nervous system activity will be more. Sympathetic nervous system, we already know. What is the effect of sympathetic nervous system on the heart rate? It will increase. If a body synthesizes more adrenaline than is required, then the heart rate will increase because more sympathetic activity will be there. The adrenaline will binds on your sympathetic receptors, okay, alpha and beta receptors. It will increase the heart rate. Here, in the same condition, for example, stress or emotions are during exercise. Okay, if some already problem is there and the person is doing over exercise or over emotion or stress hormones, okay, cortisol and cortisol, over stress hormone, that may also lead to the your heart rate increase. That is nothing but your arrhythmia. Okay, and in some cases genetic factors also will be predisposing for this type of effect. Okay, and you will be having different types of arrhythmia. Okay, first class is supraventricular tachycardia. Supraventricular tachycardia. So supraventricular, supra is nothing but above. Ventricles under, it is nothing but ventricles. Now supraventricular, what are the parts which are there above ventricles? They are nothing but atria. So supraventricular tachycardia is related to the atrial dysfunction. Okay, the atrial contraction and relaxation will be disturbed during SVT, supraventricular tachycardia. In this you will be having two types. One is atrial flutter and another one is atrial fibrillation. If the heartbeat is more than 200 to 350 beats per minute, then that is called as atrial fibrillation. Okay, and if the contraction of the atria is above 350 to 550, then that is called as atrial fibrillation. In both cases, that there is a disturbance in the contraction and relaxation of the atria. Okay, and apart from this, we will be having ventricular tachycardia, which is related to the ventricle segments. Ventricular tachycardia, then we will be having two types: ventricular fibrillation and torsade depointus. Ventricular fibrillation is nothing but rapid asynchronous contraction of the ventricles. Okay, this is a ventricular defect. And next one, we will be having torsade depointus. Torsade depointus is a phenomenon where your QT interval prolongation will be observed in case of ECG. Okay, if you take ECG, you will be having P wave, Q wave. So this type of thing you can be wave signals you can be observed in ECG. These are the signals you can be generally observed in the ECG, electrocardiogram. Okay, this represents the normal functioning of your heart. P wave represents the atrial depolarization. Okay, the depolarization of the atria. QRS complex represents the depolarization of the ventricles, and T waves represent the relaxation of both atria and ventricles. Okay, so if there is a disturbance, QT interval prolongation, if this time is prolonged, okay, then that is called as your torsade depointus. Okay, so these are the different types of arrhythmia you can see here. Now, how the heart will contract? Okay, how the heart will contract and how the mechanism of electrophysiology of heart you should be aware to know the anti-arrhythmic drugs treatment. Okay, what are the different types of drugs we are using? So based on that one, we have to see the electrophysiology of heart. Here, generally electric impulses for any contraction or relaxation, they requires an electrical impulses. Okay, even if you take in nervous system or it is like a cardiac muscle, there should be some energy. That energy here will be generated by the electrical impulses, which are generated in the pacemakers of the heart. Those are nothing but what are those? SA node and AV node. So these are the two pacemakers of the heart. You will be having SA node and AV node. So through this, the electrical impulses will generate. Okay, these electrical impulses will travel through your bundle of this and Purkinje fibers. So due to the electrical impulse transformation from these nodes to the bundle of these Purkinje fibers, your heart muscles will undergo contraction. Okay, if they contract, then you can observe the atrial contraction, ventricular contraction. Due to that force, your blood will be pumped. Okay. Now you have to see what is happening inside the cardiac cells. Okay. What is happening inside the cardiac cells? Now you see, whenever the cells which are there here in ventricle, if they overall coordinate together and contract, then only your total ventricle will be contracted. Same case you can observe with atria also. Now you have to see what is happening exactly in your atria and ventricular cells, cardiac cells. Okay. Electrophysiology of heart. Here, so the transmission of electrical impulses so the electrical or electrophysiology of heart can be represented this way. So you know already there is a charge ion balance in each and every cell. Each and every cell there will be a charge ion balance. Here, for example, the number of positive ions and positive negative ions across your cell membrane will be balanced always. Okay. If there is a fluctuation in this balance, then your activities inside the cell will start, they will initiate. Okay. Now what will happen? So based on this one, the action potential is represented as negative and positive. Okay, negative and positive. Remember, whenever positivity or positive charge inside any cell will increase, then the cell will undergo depolarization. If the negative charge will increase, then that will undergo repolarization. Here, so now initially what will happen? We will be having so this is the phase so your electrophysiology graph will be appearing like this. Okay, this is the different phases. Initially what will happen? The cell will be having recovery period. Okay, it will take rest. This is called as phase 4. Phase 4. Minus 70 to minus 90 millimoles of area is called as recovery period, which is nothing but your phase 4. In this case, the cell, whatever the cell, the cardiac cell, that will undergo resting. Okay, recovery period. It will undergo resting and it will be preparing for next beat, next heartbeat. Here, so whenever the heartbeat is initiated, okay, the sodium channels will open. The sodium channels will open. If sodium channels are opening, then the positive charge from the outside will enter into your cardiac cells. Okay, the overall positive charge inside the cell will be increased. So from minus side it will be moving to the plus side. Okay, sodium channel influx. Influx means entering into the cell. Okay, this phase is called as phase 0. It is also called as depolarization. Depolarization phase. Okay, it will reach up to plus 10. Okay, positive side, sodium. Now what will happen after that? It will have after some time. Okay, after some prescribed time, it will undergo the sodium channel along with sodium channel, potassium channel will open. Okay, potassium channel will open. The potassium channels will allow the positive charges from the inside to the outside. That is called as efflux. Okay, potassium will go outside of the cell. Potassium efflux. This is called as phase 1, which is called as repolarization. Why repolarization? Because the overall place charge inside the cell is decreasing. Sodium is entering, okay, but potassium K place charges are coming out. Potassium also carries the positive charge. So the overall positive charge is decreasing inside the cell. That means negative charge is increasing. Okay, because as I already told, both will be balanced. If positive is coming out, negative charge will increase. That's why we are writing as repolarization phase. Okay, this is called. And after this one, we will be having steep phase. This is called as plateau phase. Okay, plateau phase. Okay, the ion exchange will be balanced. Okay, how many amount of positive charges are entering inside? Same amount of positive charges will be coming outside, so that the balance, the voltage balance will be there. That is called as the plateau phase. Okay, plateau phase or is also called as phase 2. What will happen here? Potassium efflux will be there. Potassium will be coming out, but calcium channels will be opened. Calcium channels will be opened. So calcium channel opening causes the influx of the calcium. Okay. So calcium is entering inside, potassium is coming outside. The voltage will be balanced. That's why you will get plateau phase 2. Okay. This is for some time. After that, it will be followed by your phase 3. Okay. Phase 3. This phase is called as again repolarization phase. In this phase, the potassium efflux will be there, but the calcium influx will stop. Okay, at this phase, calcium influx will stop. So calcium influx stop, potassium is coming out. Negative charge increases enormously inside the cell. That's why it is moving to the negative potential. Okay, so it reaches up to here, and again this is called as your phase 4. Same. Okay, phase 4 is called as recovery period. Clear? After recovery period, again it will start same process. This is one bit, next one is other bit. Clear? Now, in case of arrhythmia, you know how the beats are regulating. Clear? So for a normal human being, 72 beats per minute. Okay? 72 beats per minute. For example, he is having 1.1 beat per 1 minute. This is 1 minute. For example, he is having 1 minute per 1 beat per 1 minute in a normal human being. In case of tachycardia, it is nothing but the number of heart rate will increase. The number of beats will increase. That means in 1 minute he will be having. Take example as 2 beats. For example, if you take 2 beats. Clear? This the number of beats we have to decrease. Okay, now what you have to do? You have to decrease the number of beats. If you want to decrease this phase, you have to inhibit the sodium channel. We can inhibit the sodium channel. Here we can inhibit the potassium channels. Okay, and here you can inhibit the calcium channels. If you inhibit this one, then the process will be slow. Okay, the process will be slow. Again, it will be slowly will go, slowly it will come down. Okay, so that now the number of beats has been reduced. Okay, so this is the target for your anti-arrhythmic drugs. Okay, you can use either sodium channel blockers, potassium channel blockers, calcium channel blockers, and apart from this, you can also use the beta blockers. Okay, you can also use the beta blocker. Why? Because you already know that if sympathetic nervous system is activated, your heart rate will increase. So if you want to decrease your the heart rate, then sympathetic nervous system blockers can be used. Those are nothing but your beta blockers, because beta receptors are present on the heart. Clear? So based on this one, Vaughn William, a scientist, in 1969, he gave a classification for anti-arrhythmic drugs. It is called as Vaughn William Classification. So in this one, you are having 4 classes of drugs. First class is nothing but your sodium channel blockers. Class 1 is nothing but sodium channel blockers. Voltage gated sodium channels will be there in your cardiac cells. They will be inhibited. Okay. Again, this class 1 has been divided into 1A, 1B, and 1C. So there is a difference between the 1A, 1B and 1C. Their recovery period. Okay. So it is again classified based on how much time they will bind to the channels, sodium channels. Okay, based the drug classification based on how much time they are going and binding to the sodium channels. Clear? So in case of 1A, you will be having two types of sodium channel. One is open state or activated. Other one is closed state or inactivated. Okay, this will be generally bordered by a H gate. This is called as H gate. Okay, so this is the open state and this is the closed state. So it is not like that the drugs will completely block the sodium channels. Okay, they will block the sodium channels so that the amount of sodium passing will be decreased. Okay, clear? So now, based on this one, this classification has been given. 1A class of drugs bind to the open stated sodium channels. Okay, and they will block for 1 to 10 seconds. Open state sodium channel, they will block for 1 to 10 seconds. After 10 seconds, again the activity will be regained. The sodium will again pass. Here, and case of 1B, they will block the closed state of sodium channel for less than 1 second. It is already in closed state. We cannot block for more time. That's why only 1 second. Clear? So this is about the 1B class. After 1 second completed, again the channels get activated again. Okay, little amount of sodium channels will pass from one side to the other side. And next one is 1C, class 1C. They will block the open state. Okay, open state or activated sodium channel greater than 10 seconds. Okay, greater than 10 seconds. These are very powerful anti-arrhythmic sodium channel blockers. Why? Because the recovery time is more. They will block the channels for more than 10 seconds. That's why they are the powerful or potent sodium channel blockers. Okay. If you see the examples in 1A, you are having pyridine sulfate, procainamide HCl, diisopyramide phosphate. Okay, and for diisopyramide phosphate, you are having the SAR and synthesis part. So you have to see the SAR and structure activity relationship and synthesis part. And in case of 1B, you are having phenytoin sodium. Next lidocaine HCl, tocainide HCl, and mexilidine HCl. And in case of 1C, you are having lorcainide HCl. Okay, this is about class 1 drugs. Okay, so as we discussed earlier, Vaughn William classification consists of 4 classes of drugs. First classification is sodium channel blockers. Second